Hi all, this is Remy with the Center for the Advancement of Sustainable Energy, and in this video I'm going to go over with you how to collect all the data that you need for submitting your wind challenge project online. So we have testing days that will be sitting with the wind tunnel in a location on a Saturday where you can come in and safely test in our wind tunnel with our energy monitoring equipment. But if that's not an opportunity for you, we can help you collect that data using various cheat sheets that Kidwin provides on the submission form. So the first thing they're going to want from you is your wind speeds. You're going to need to know the approximate wind speed of your fan. If you don't have an anemometer to be able to calculate that, there's this great cheat sheet that tells you for different kind of looking fans at different distances from your wind turbine about the wind speed. So for my box fan, and assuming that I'm only 25 centimeters, so I think I'm probably closer to like 100 centimeters, from my fan, I'm at about 2.3 meters per second, according to this cheat sheet. So in the turbine data form, I will record 2.3 meters per second. Okay. And you can download this form online, or like I said, you can just keep a notebook with this information in it and know that you'll need it for submission. The second thing that you're going to need is to understand the rotor diameter of your wind turbine. So again, Kidwin has a really nice cheat sheet that's going to teach you how to do this. But to understand the swept area of your wind turbine, you're going to need some geometry. And it's just the area of a circle. Assuming that you have a horizontal axis wind turbine that looks like this, the swept area is going to be based on the rotor diameter or the rotor radius. So all you need to do to get the radius of your circle is to measure one blade from the tip all the way to the middle of your hub. And you record that as your radius. To get the diameter, you would double that. So you'd go from one side to the other side of your circle, and that would be your rotor diameter. So for the online submission, you need rotor diameter in centimeters. So make sure that you're using a ruler that has centimeters, or if it has only inches, that you can convert it to centimeters. Okay? From tip to tip, the diameter. And then the computer program is going to use that information to calculate your swept area. So that's the second thing that you need. And I have a ruler here, and it has centimeters on it. And I'm going to measure my rotor, but I'm only going to measure one side. And my rotor radius, actually does not have centimeters. Is 10 inches, so I'd have to convert that to centimeters, which is probably about 34 centimeters. And then I would have to double that, so I'm at probably about 70 centimeters. So 70 centimeters is my rotor diameter. Make sure you write that in. Okay. The next thing you need to have is some resistance on your circuit. So that resistance can be a couple of different things. You may have the resistor that came in your package. It's like a little wire that has like a little ceramic barrel in the middle. You may have a resistor board that looks like this. And if you don't have any of those, maybe you have a light bulb. That can also be your resistance. And if you're using the resistor in the kit, it's a 30 ohm resistor, and you can check that using your multimeter. So if you grab your multimeter, all you're going to do is you're going to clip to one side of your resistor and clip to the other side of your resistor. And using your multimeter on the 200 ohm setting, which should be the very bottom, and does not want to do anything. You should be able to get a reading off of your multimeter. And again, there's a cheat sheet that Kidwin provides you that says you're going to hook up your resistor to your multimeter, and you're going to go to the 200 ohm setting at the very, very bottom of your multimeter. I left my multimeter on all last night, so it just may not be working for me right now. So if you come to the wind tunnel, we use a 30 ohm resistor that is built right into the Go direct energy sensor, and it says it right on the side there for us. The one in your kit is also 30 ohms, so you may not have to measure your load if you're able to know that it's the one that we provided you in the kit. Okay. And then this is the last bit of information that you need, and this is the big one, okay? This is where you're going to measure your output voltage. And so it's important to understand that your output voltage is not the voltage that when you just have your wind turbine, you stick your blades on, and then you hook it up to your multimeter. That is potential voltage, but it's on an open circuit. So it's a very different number from when you incorporate your resistor into that. So you need to be sure that you're adding the resistor into that circuit in parallel. And so again, Kidwind in their infinite wisdom has provided us with a wonderful cheat sheet that shows us exactly how to hook this up. So it says your red side or your positive side of your turbine is going to be connected to the red side of the multimeter and also the red line side of your resistor. And on the black side, it's black to black to the yellow line on your resistor. Okay? So this way you're going to have your circuit with both the wind turbine providing electricity and your resistor providing resistance, which now is going to make it so that your turbine is going to be not in an open circuit, but have resistance, and the numbers are going to look a little different. And so when you turn your fan on, you set your multimeter to that same 20 scale in the direct voltage section of your multimeter, the 20 and the V with the line and the dotted line on the left, then you should be able to get a reading. And that is the reading that you're going to record. Now, if you're super excited, you are welcome to also provide an amperage, which is in the A section on the right, which has the line and the dotted line. And you're probably going to be in the 200 with the little m, that's milliamps. Or you could even be at 20 milliamps. And while the wind turbine is running, and you can flip between your direct voltage and your amperage in milliamps, and you'll record both of them. If you multiply those two together, you'll get a milliwatt, which is a really, really, really small watt. When you go to the online submission, all you need is that voltage, and then the program will compute your wattage for you. But this is in case you want to just double check yourself. And the last thing that will happen is once you input your wind turbine, your wind speed, your rotor diameter, your resistance from your load, and your voltage from when you have their turbine performing, it will use that to calculate a turbine efficiency. So you're going to get a milliwatt rating, and you're going to get an efficiency rating. And that is what you're being judged on compared to all the other teams. I hope this was helpful. If you need more help, please feel free to Flipgrid us, email us, or come to an open lab, and we'll be happy to help you. Have a good one.